Okay, well, welcome everybody. It is 1 o'clock here in Japan, so we're going to get started. Just a reminder, this session is being recorded, so if you don't want to be recorded, don't turn your video on and don't say anything. As ever, please note well the note well. Hopefully by this stage in the week and this stage in our IETF careers, we understand the rules around participation here, but if you don't, you can go and read up on this. And obviously abide by the standard rules of conduct. Be nice, be kind, be productive, and we'll all get along just fine. So for folks online, obviously you're already online, so presumably you've achieved this already. For people in the room, ideally make sure you join with the on-site tool in Meet Echo. Just easier, simpler bandwidth, doesn't have the video and stuff on it. If you can't, for any reason, join the light client in the room, please do sign the blue sheets, because the way that we take attendance is through the Meet Echo record. So ideally, please join the on-site tool and everything's done for you. But if you can't do that for some reason, there's a QR code outside the door. And if you could scan that, that would be much appreciated. And remember to wear your mask unless you are the active speaker at the front. I guess I could take mine off if I wanted, but yeah, if you're actually presenting up here, no worries. But if you're in the audience, please do keep your masks on. So we've got a bunch of resources for SCITT here at 116. They take the usual form. They're available in the usual place on Data Tracker. But if you're not familiar with the Data Tracker locations or the session locations, there's some notes here, and you can pick these up from the home page. So the minutes there will be available forever, essentially, and the meeting materials, so these slides and the slides that are going to be presented by the presenters are all up on the SCITT116 meeting site. So you can go back, check these, get them later, and if anything isn't there or you have other questions, you can always email me or Hannes, and we'll help you out. So yeah, prettiest slide in my deck. Hannes is already taking some notes. It's always great to have a second collaborative note taker. Do we have a volunteer? The big payoff, apart from great pride and prestige in being a note taker, is that you do get to have the cute hedgehog on your screen permanently in the corner. So do we have a second note taker to help Hannes? Anybody? Okay, Kay, thank you very much, Kay. An experienced note taker, I realize. Thank you very much. Good. So quick update, state of the union. Obviously, last time we didn't have any adopted work items, so it was a very new group. Now we've adopted 2. So we've got the architecture, and I make the note here that includes the security model, because of course one of our required deliverables from the chartering exercise was to have the security model included somewhere, and it's included in the architecture. There's been a lot of work on that. And also a specific use cases document. So starting with the initial focus on software supply chain, which presumably will be expanded out later. But for now, we've adopted just this one to really make sure we bottom something out. And both of these hopefully will break the kind of chicken and egg that we've been having. Those of you who've attended the interim meetings, we have a lot of discussion about discussions, and we expend a lot of words talking about words. And at some point, you've got to work out which of these discussions are actually important. And so we figure by doing the architecture first, that will at least tell us which things we need to talk about. And then what names we give to them and stuff, we can then have that discussion in context and know really what we're doing. So yeah, we have had a lot of terminology discussions. We have a lot of overlap. For those of you who are not regulars in SCITT, we have quite a lot of overlap with other groups, with COSI and CBOR and various other security teams. And everybody has subtly different language that they like to understand and use. So hopefully we'll break that chicken egg issue. To which end, we've done a lot of work since 115. We have almost weekly interim meetings, which appreciate is quite a marathon for some people, but it's really helpful for getting the work done. We've had on the GitHub on the official adopted work items, not to mention the unofficial ones, 44 issues raised and 8 closed, which if you're writing software, that doesn't seem like a great progress, but for spec writing, it's pretty decent. And 17 PRs on those issues, of which 13 are merged. So good, fast response. So do pay attention to the work that's been done here and the updates on the architecture, because it's quite a lot of progress since last time. And just in time, Hannes has got his hand up, so I was about to finish. So yes, Hannes, go ahead.
Yeah, I just wanted to add that we are going to set up the doodle poll to check for dates of further weekly or bi-weekly meetings, depending on what the group likes. We had that discussion at the last conference call, which was a week ago, but I want to also repeat this on the mailing list to see whether there are any changes in preference. So
yeah, good point. I think in general we set the expectation of reassessing at each official meeting. So that will be a good thing to do. Thank you, Hannes. Okay, so having had no feedback to the mailing list on spec hacking, I'm not going to allow any now, but if you do have AOBs or spec hacking topic, agenda hacking topics rather, we have a decent AOB section at the end of this. So with no further ado, Henk, if you'd like to come and remind us of our context, that would be fab. You may.
Yeah, sometimes I forget it.
I like how we're both color coordinated with our masks.
I try not to eat the mic while I hope is this on? Yeah, I can't hear myself.
I don't know. Hannes, can you hear?
Beep, beep. Oh, now I can hear myself. So this sounds better. Hi, I'm Henk. This is now on. And yeah, I'm doing a quick recap introduction where we are, the current state of affairs slides. Next slide, please. So as I think our dear chairs already elaborated on, this is redundant apparently, we adopted the use case document?
Yeah.
Adopted, or at least adopted IDs. Detailed use cases will be elaborated on later. There's a lot of things happened in the architecture, although it is not all visible in the update. We will come to that. One of the reasons is related documents, which you can see below. We started with a document that was very SCITT egoistic. We only thought about ourselves as we wanted to build a solution. And then we realized what we are doing here and what we are using here is not SCITT specific, but we are actually doing cozy work for signed Merkle tree proofs. So, or we will elaborate on that, but in a nutshell, I tend to steal other people's topics. So in a nutshell, that is the overview of changes. Next slide, please.
Come on.
Sometimes this takes a while.
Yeah.
So a ton of discussion has happened. By the time slides are stalled, a ton of discussion has happened on something that is very unusual for the IETF. We had weekly interims. The only thing that comes close to this is the fortnightly interleaf meetings of core in CBOR that is very interconnected. You could almost call those weekly interims, but for starters, especially as we had a lot of fresh IETF and newcomers people here, coming from supply chain entities and supporters, there was a strong impulse on having weekly get to know this meetings. And we discussed a lot of details, and now the slides Thank you. I can stop my storytelling now. So while we were working on the architecture, we encountered or basically created for ourselves and for everybody new challenges. So one of them I pretty much introduced already. Merkle tree proofs are not specific to SCITT, and it is a challenge to create a generic Merkle tree proof format for SCITT, for COSI, sorry. And again, I will not steal content from that, but there are a lot of flavors of trees, and unfortunately structure homogenization is a tad bit tricky. Then we were basically specifying two messages in SCITT, which is the original issuer sign signature, the sign statement that is coming from the interested supply chain entity about a product, an object, or an artifact. And then we had those SCITT receipts. And so they are basically also now coming to COSI because these are profiles of SCITT, sorry, of COSI headers. I'm always mixing them up now because they're synonymous sometimes to me now. COSI headers are frightening to people because they are so powerful and they give you so many options. And sometimes it's actually not that frightening when you actually specify how to use them. But there's no standardized way, no guidance way, no best current practice way how to guide implementers how to use the COSI envelope. And that is now another challenge we brought to COSI. We put in a big word, we called it COSI profile. One of the first feedback was, that's a bad name. Let's find out what this actually is. It's the way how to use COSI in a convenient way so that you can't make a lot of mistakes. I want to say it like that when implementing it. And finally, on this slide, there's still an API section in the architecture. And APIs are basically for how to get at the stuff that is in a append-only log. How to get the data that is made authentic and believable via the SCITT architecture and these two COSI solutions. That's not really architecture. That is a bit of our architecture, but I think we want to split that out. And the operations will be fueled A, by use cases, and B, inspired and be influenced by the message formats. Because sometimes you must include something in a generic Merkle tree proof, and you have to take into account that you want to, I don't know, content negotiate that on an API level. So there will be a cross-pollination in another document that we will create in the very near future about operations, most certainly a reference API, and maybe even going to a standard API, but we can't say that yet. Next slide, please. So you brought some numbers, somebody brought some numbers. I'm going into a very specific number, and that is number 16, that it was a PR, talking or trying to change terminology on the architecture document before it becomes the next version. He is submitted to the IETF. There were a massive 113 individual comments that all somehow had relevance. It was a lot. These ended up in 30 issues. And I wanted to highlight that a lot of valuable feedback was there on different parts on the architecture. It was very separate topics. And if your topic of interest was lost in PR 16, please look at that closed PR on GitHub again, and maybe raise a own PR about that on the document, or create a suggestion on an existing PR, or at the very least create an issue. Any comment you make is super valuable, but result in a lost in translation by editors. So if you can have a specific contribution as a suggestion or as a PR, that is way more useful, even if you might not be certain about the wording, that can be ironed out. But then there's something to be actually worked on sequentially by the editors meeting. We will have editors meeting and we will take care of it. We will help the whole working group fixing everything you want to have in. We will find consensus on the list, but the proposals, please look at the GitHub. But if you are also uncomfortable with GitHub, there's a mailing list. We will copy new, old. We can do that. Next slide, please. Yes, so it was already elaborated on, and this is my last item I want to talk about here myself. Unfortunately, so I'm sometimes called a terminology enthusiast, and I would do it too much. In this case, it was really necessary to do hard decisions. We had the term claim used in the architecture. We are using CBOR, and in CWT, a claim means something entirely else. It's utterly confusing for someone who is not used to IETF documents. So that got rid. We agreed on, I would say, best consensus alternative placeholders, and that's science statement that you create from a statement. Walking through that is not necessary. The architecture will explain this too, and other people will talk about it. The thing the science statement ends up in the append-only log. We're calling it that. We are talking a lot of trees. I've only talked about trees before here until now, but it could be a super hardened database that you give every guarantee on the world for that it will only append and never delete. Your implementation choice. But therefore, at the moment, append-only log captures basically the qualities of that retention system, building block, sorry. Well, and then if that is in there, and you got this receipt, it's probably a Merkle tree proof, then you can combine those. And we call that a transparent statement, if those are combined. Signed statement, Merkle tree proof for SCITT in the unprotected header, transparent statement. I think it's very important to keep these terms straight, otherwise we never know at which point in the, I don't know, topic you're talking about, and we are always confusing ourselves. So that has been solved. Everything is about artifacts from the supply chain. We understand that is also not a good term outside the world of software use cases. Everybody not working with software use cases already says an artifact is a data document. It's not my car anymore, or not my wing of an airplane. There are other things. We understand that. We're keeping artifact for now. This will be another terminology for discussion, but it is not as important right now. And then I really want to highlight that there's a long and successful alignment of terminology with RATS, because RATS is supporting infrastructure for SCITT in order to make a SCITT service, the transparency service, the system you build with SCITT more trustworthy. It would be fueled by RATS components and RATS roles. And in RATS, there's this thing called an endorsement. It's a signed statement that a target of evaluation can't make about itself. So a car can tell you a lot of telemetry, but it can't tell you that it's red. It has no camera pointing at itself, and it can't collect that claim. That is endorsed by an external entity that is in RATS. An endorsement, it is basically current state, it is not coming from the attester. And these endorsements are also, this term endorsement is also used as payload for the statements that are in these append-only ledgers. And at the moment, we would like to call them supply chain audit results, because there's a very specific issue here that is checking the whole append-only log. That's one of the main use cases, is transparency, that after the fact, you can have someone look through all these things and find out, was it actually that way? Did everybody do their part? And then there's an audit result. And then actually this auditor endorses some parts in there. That technically is also an endorsement. So there is some overlap here again. If an auditor puts a statement into a append-only log, at the moment we are calling that an audit result. That's also a placeholder. Please stay with us here. I know terminology is hard, but we have to have a stable point if we want to move on with actual solution space. And I think that's my last slide.
It is. Thank you, Hank.
Okay.
No hands in the queue, so Kay, if you can come and take an earned break from your note-taking.
Good afternoon. Hank is much taller than.
You just press it down. There's no real.
Oh.
Okay, nice. Hi, everyone. So my name is Kay Williams. I am reporting on our detailed software supply chain use cases. These were pulled together by many people in the community. So the editors for this document include Hank Burkholz, Bob Martin, Dick Brooks, Yogesh Deshpande, and also Brian, and I'm forgetting his last name right now, from, what's that? Brian Knight from Microsoft. And I get to do the reporting on it because I'm here in person. So, and I did help contribute, but many people helped to contribute. As you might know from previous sessions, as we chartered SCITT, we said that SCITT, the architecture would be payload agnostic so that it could carry information about any type of supply chain artifact that as we mentioned earlier. And we also said we would start with looking at software supply chain use cases to help us focus. What we did in the working group is we identified quite a number of use cases. There were 9 of them, and I have them listed here. And there's a link to the document in this, in the slides. I'm not going to go through all of the use cases. Again, there are quite a few. Some of them overlap with each other. But what I want to call out from this slide is just the range of use cases that we considered, or scenarios that we considered. We looked at software, we looked at firmware, we looked at different or sort of phases in the software lifecycle, and where information might need to be transferred and evaluated during those phases. And the phases include things like assembling components from multiple suppliers, writing code, committing to a source code repository, packaging software, distributing software. We looked at different distribution scenarios. We looked at cases where it might be an operating system provider gathering components and then distributing as part of an operating system. Firmware was another distribution scenario. We looked at different environments, things like what's the word I'm looking for? Air-gapped environments, so deployment scenarios, deployments to air-gapped environments. We looked at, again, part of software life cycle. We looked at the need for being able to express information about what the contents of software are, and then also as the software is released, but additional information comes out about it over time. So capturing things like reports of vulnerabilities, mitigations to software, updates of software. So our use cases cover, this full range of scenarios. So now what I'll do is we'll kind of talk about what a general use case or a use pattern looks like, and then describe some of the blocks for this general workflow. So again, in general, Hank talked about statements, and so we're using the terminology statement to describe a document that is shared. The personas involved, the 2 major personas include statement issuers. They're the ones who create statements, and then statement consumers, and they're the ones that make use of the statements for a variety of purposes. And then the statements can be about, we're still working on terminology here. In this slide, I'm calling it, they can be about objects, but where an object could be a software artifact, but it can be other things. And I'll describe what some of those other objects will be in future slides. Next slide, please. So statement issuers, these can be, essentially they're individuals or organizations or processes, anything that creates information about artifacts in a supply chain. Some examples of these include developers, so individual developers, but also source code management systems, build systems, CI/CD systems, the systems that do packaging of software, systems that release software, and then other, again, individuals that might provide information post-release of software. So people who first-party and third-party do audits of software, and analysts, for example, security analysts. So these could all be statement issuers. And some of the activities that the issuers participate in include making statements about software artifacts, but also they have a need to relate statements to other statements. So make a statement that associates different statements. They have a need to make statements that refer or update, augment, or invalidate other statements. So this is a relationship from statements to other statements. And then they have a need to distribute statements. So, you know, if I'm in one company, I make a statement, I might want to share that with all of the consumers of, if it's software I'm sharing, I want to share that with the consumers of my software. Next slide, please. Here's some examples of statements. Statements might describe who produced the software, what is contained in it, who distributed the software. The distributor might be someone different than the person who produced it. Statements can describe assessments that were performed on the artifact. So it might be some security testing that was performed, maybe a security analysis, you know, a design, a review, security review of the design of some software. Other statements could be about weaknesses or vulnerabilities found in software, possibly statements about mitigations to those vulnerabilities. Again, statements can be about corrections, updates, augmentations to previous statements. And then statements can describe relationships between previous statements or between a variety of software artifacts. Next slide. Objects, again, I'm using the term object here. You know, we're still working on technology, but it's the thing that the statement is made about. In the case of software, it can be about a variety of different types of software artifacts. So source files, source code repository, commits, binaries, packages, containers, disk images, firmware images. Other objects could be other statements. And then also for SCITT, we look at cases outside of software. So physical artifacts, and things like build environments is, you know, could be another object of a statement, a description of the contents of the build environment itself, or processes that were followed in building software. Next slide. Okay, and then our last persona is a statement consumer. Again, these can be individuals or processes. And some examples include integrators, suppliers, people who procure software, you know, and need to evaluate all of the, you know, typically this happens at a corporate level. So someone who's evaluating all the software that's used inside of an organization. Risk managers, these could be organization or, you know, even regulatory, auditors, analysts, and customers. And the activities that statement consumers perform include locating sources of statements. So if I'm an organization and I want to require statements from all of the suppliers of software to my organization, I need to know where I can find the statements from those suppliers. I need to be able to filter the sources of statement to those that I, as the consumer, trust. So I might trust statements that are made by some reputable organization, but maybe not by, you know, some organization that I'm unfamiliar with or doesn't have any sort of credentials. I need to be able to filter and download statements. I need to be able to verify the authenticity and the integrity of those statements. And I also need to, it's important because of this idea that statements can update other statements. I need a way to obtain new or updated statements as they become available. And let's see, so I need to be able to aggregate statements across maybe different statement providers, because there could be the producer of software, but then maybe some third-party analyst who makes statements. I need to be able to get a single view for some software of statements across many organizations. And then the last thing is that I want to be able to use statements, very common scenarios, to be able to use statements to apply some sort of policy regarding whether I will use it, in the end, use that or allow that software or make use of that software, or allow it to be ingested for my use case. So that covers our software supply chain use cases, the sort of the detailed working through the sausage part of the process, and then also our summary of personas and the activities that they take. Any questions?
There's no one in the queue, so no, then thank you very much, Kay.
Great, thanks.
Great update, thank you. Okay, so the next part is me. And I'm kind of hoping if I speak loud enough, the camera will turn around to look at me, because I don't want to move. Maybe I'm going to have to. Come on. No, it's not doing it. Okay. Let's just do. I'm going to do this anyway. So folks watching remotely, you can't see my my face, but that's no bad thing. The slides are the important part. So I'm just going to give a quick readout of the sort of experience from the hackathon with a couple of notes. The note on the screen here that most of what actually happened at the hackathon itself was spec hacking and talking about terminology and how it's working. There you go. And things like that. But I'm only going to talk about the code thing because Cedric and others are going to talk about what we did with the architecture document. The other thing to note is that I did finish off quite a bit of code during the hackathon, just to prove the point, but there was a lot of pre-work done as well by a bunch of other people. So this is a kind of roundup of what we were trying to achieve, which really was to show that we could have multiple implementations of what we're currently planning, just to make sure we're on the right track, that we're building a good architecture and a good spec that can be practically followed. So obviously, we have to be very careful of what we treat as true and what we treat as potential. So with no actual specs and only a couple of adopted work items, we have a lot of things that we did that are kind of furniture, but what we really wanted to show was that the sort of 8.1.2 in the contemporary version of the spec for retrieving receipts and all of the sort of interfaces and stuff was plausible and practical, and that we could actually get this miracle of a portable Merkle tree proof into something that looked a bit like the 6.1 envelope and claim format using standard COSI. So this is what we're trying to do. And very importantly, we were not, and for some time I suspect are not, going to do anything with interoperability of the payload itself, but rather the interfaces for getting the payload. So can I trust that I have a legitimate statement from some portable supplier of SCITT? That's a good question to ask. Am I going to provide interoperability and semantic equivalence between an SPDX SBOM and a Cyclone DX SBOM? No, we're not. That's not a good question to ask us right now. So in short, what did we do? We got some decent code done. So my team did one of note. I wrote a bunch of the code in the open source repository, but the implementation in the Archivist product was done entirely blind by some of my software team. So I just gave them the architecture doc. They took standard COSI documentation stuff and wrote it completely blind before I picked it up, and amazingly it actually worked. So that proves something about the quality of the docs that do exist in this space. Transmute and Ori have a very kind of structurally similar looking thing for dealing with claims and receipts totally independent implementation. And in the middle of that, we have the open source SCITT API emulator, which was largely worked on by Mike Reichert at MSR, which kind of guides and tests the interoperability. And what we had in the end is this emulator in the middle, sort of defining a neutral and standard client. And you can register claims, arrange them into feeds, you can get receipts, you can verify them offline. I'm not sure if the Transmute one can technically do it offline, but you can download it and run it yourself. It can. There you go. Yeah. So so pretty decent result really for what we were trying to achieve. It's thin but important. So how does that look?
How many people participated, out of curiosity?
That is a great question. So our table was overflowing. We ran out of seats. So what, 10, 11 people, I guess, at our table. In terms of the code here, an awful lot of Mike, but I know Mike Procock also has committed some code there. Steve, I think, did some work there. Me, Ori, 3 of my software team. So in terms of sort of contributors, I guess we've got a total of 10-ish people writing code and 10-ish people doing spec, with some overlap in those 2 10s. But yeah, that kind of number. Nobody's demurring, so I guess it's about right. So what the thing looks like in this this emulator has a very simple interface where anyone can create claims, submit them, retrieve them if you've lost them. I think that's a very important point for people who are asking, why do we have services? Why is there a REST interface? Why isn't it just a PKI and timestamps? Well, because in truth, people already don't enjoy storing, organizing, indexing, searching, and backing up all of their PKI nonsense. And this is only going to get worse if we did it that way. So the retrieving piece actually is a super important bit of the filtering, listing, the reliability, the A in CIA that everybody always forgets about when they go too far down the security triangle. That's what that's for. And then at the end, verifying the receipt. And that can go up to any number of backends. So as we say, we wanted to have a standard client following the architecture that could use any implementation. So there is an emulated CCF backend. My software team in my company built a proxy for our REST services. And in principle, you could just add anything else on. It's super easy to add a slice through. And what it results in the end, kind of proof of the pudding, is that you flow left to right. By the time you get into the quorum DLT, in my case, or QLDB in the Transmute case, or CCF in the emulator, it doesn't matter. But by the time you get to the far end, the claims are written into a Merkle tree. The Merkle tree proofs are then transmitted back. And what we ended up with was a compliant CBOR COSI receipt with the Merkle tree proofs in, which are verifiable offline. The details of that, obviously, people do ask a lot of questions about the centralized service and things. All of the client piece is open source and standard. All of the verification piece is open source and standard. So even on the archivist backend, you'd never need to talk to it again. It uses standard CBOR2 and PyCOSI libraries and standard RLP from Ethereum Foundation and Consensus for validating all that stuff. So largely proved the point. In terms of experience, I won't go into the details of this. You can look at it with the magnifying glass on the slides if you download them. But just to show the kind of the RESTful flows, mapping product. One thing that I thought was really important about this is that the Archivist product already exists. We built this thing like 5 years ago. And yet the mapping of the interface flows to what's in SCITT is really actually quite clean. It looks like this. This is the most complicated thing for submitting a claim, and it's not surprising because they're countersigned. All of the other things are basically straight through proxies. The structures work, the security holds, the flows and custody of various tokens all work. So I was very pleased with that. The one thing that isn't straightforward is the verification piece. And as Hank already noted, having a totally standard representation format for Merkle tree proofs might be difficult. So we could have done this, but I wonder if it's a conversation to be had about whether the forensic verification needs to be standardized in such a plain way. You know, the open source code exists, as I say, it can be done. You can hand roll your own. If we really want to go down that line, we can. But I think it would constrain things a lot if we were to force people to have a very specific single Merkle tree format. Personally, you know, with my chair hat on or off, I don't care. My product's based on Merkle trees, so I'm perfectly happy. But I think there's a lot of scope for other companies and other implementations that don't use those structures, who would otherwise be perfectly legitimate providers of SCITT, that maybe be frozen out. So I wonder if that's a thing we need to consider. So takeaways, sort of successes, slightly less successes. I think it was a great thing. So my team did the hard work in the back end blind from me doing the fun work in the front end, and it almost perfectly lined up first time, which is a good testament to the work that's in the architecture, and of course all of the existing shoulders of giant stuff from Cozy and Seaboard that we're relying on. That's all great. We broadly demonstrated the practicality of the interface flows. Interestingly, one of the things that was the hardest and the most uncomfortable for me in doing the implementation was about how the client countersigns things. And it turned out, well, in parallel, the guys working on the architecture spec and the thinking also came to the same conclusion. And by the time I complained about it, it was already reverted. So that was good. There is a question mark over long-running operations. Clearly, when you're dealing with decentralized or distributed systems, there are all kinds of reasons, not just the obvious kind of blockchain is slow reasons, but there are all kinds of reasons why it might take a while for a properly bulletproof claim, or even a receiptable statement to end up in reliable storage, which is kind of the point at which it's responsible to return a receipt. And you definitely don't want to specify synchronous blocking interfaces as necessary when we're talking about systems of the speed and scale that we're talking about. So I think maybe a little more thinking about that. But the asynchronous model that's already suggested already works. So, you know, maybe just a matter of pressing the delete key, could be that simple. And the note again that we really do need to have flexibility in the tree algorithm. We might start with one, that's quite reasonable. But I think having options to expand that in the future would be sensible. We broadly demonstrated the data structures are reasonable, with, again, one tiny note. This was the first time that the particular guys in my team had worked with Cozy and Seaboard. They really liked it. And to be fair, one of them's been working in crypto for 20 years, so it's kind of expected. But we really like the expression for actually handling the data when it's data. It was a bit uncomfortable when it came to passing across boundaries. And in reality, we're going to be passing across a lot of boundaries with code of various quality and reliability. So we opted to kind of harden that by turning it into base64 and JSON for the kind of big interface parsing. And I think it's worth considering that. Yeah, otherwise, yeah, we don't want to make this hard to write and hard to maintain because people won't do it, right? So that's a thought. And yeah, otherwise those were the two sort of big issues. Otherwise, the interoperability of the interfaces, data structures all seem to work. They're all compatible with themselves. The Seaboard that's spat out by my implementation looks the same as the stuff that's consumed by the transmute one. I didn't have to modify the emulator client at all to work with our implementation. So by and large, accepting that idea that we don't want to standardize the payloads themselves. I think that's impossible. I think we'd never get published. I think it was a great exercise, and I think it proves that we're on a good track with the architecture. So all in all, pretty decent. Hannes, you are in the queue.
Can you say a word about the counter-signing problems that you ran into?
Yeah, there were a couple. One, yeah, of different sorts. So there, in the group, we have a lot of discussion about identity. And I think when those discussions come up, it would be really useful to reset. Maybe we should have a standard slide with a diagram on it with the various principal actors shown, because invariably the discussions kind of blur multiple different identities together, and then they blur those identities with the credentials that are used to represent those identities in API flows, and neither of those is a good way to resolve a technical problem. So one of them was simply during the blind exercise with my guys writing stuff. We already have identities, we already have relationships with identity providers, we already have OIDC for the sort of application credentials and things and stuff. You know where the claim is coming from, and so having a counter signature in the which isn't there anymore, but at the time in the contemporary spec, also signing things that many times with a different key, with a different hierarchy that you now have to check, actually introduces potential for error and no benefit. And so yeah, there was some issues there. And then a very mundane thing, but it actually cost me the most time in writing the emulator implementation, was just a little bit of a disagreement about how to represent the things in the cozy structures. So we were putting it in a sign one envelope, and the standard implementation was putting it in a countersign v2 wrapper. And so, of course, I had marshalling problems in there. But that, as I say, by the time I thought to complain about that, it had gone away, so it was fine. So there you go. Any more questions on the hackathon, or this is all in GitHub and open, and we'd be very glad for other people to play with it. So if you don't want to say anything now, but you're interested, please do message me or anybody, join the Slack channel, and we'll get you on board. Cool. So on to the main event then, Cedric.
So hi, I'm Cedric Fournet. So I'm one of the authors of the architecture. You may recall last time Antoine going through the architecture, and last time he focused on two very important aspects of the architecture. One of them was the threat model, which we had completely rewritten. It's particularly describing what are the security expectations and what is the threat model for that underpins the architecture. The second one was the different places where we had the policies for issuance, for registration and verification, and why we are focusing on policies for registration. So I don't intend to do that again. In particular, I don't have much on the core security properties of the architecture today. What I plan to do is to recall the basic of the architecture, reviewing all the active issues that we are currently considering, and also trying to discuss some of the frequently asked questions that we get about the architecture in terms of usability, scalability, and functionality, as a complement to what we have done the prior times. Please ask questions as we go. I think I'm scheduled for almost an hour, but I'm not going to use all of that. So I hope we have plenty of time for discussion. Next slide, yes. So here are the core concepts. It's also a good way for us, or at least to me, to get used to the revised terminology. So we have three parties for the supply chain. On the producer side, we have the issuers. On the consumer side, we have the verifiers. And in the middle, we have the transparency service, or registry or notary, that is there to guarantee that all parties share the same complete record of statements that have been made about the artifacts that are going on the supply chain. So as we recalled earlier, the architecture, what we are trying to standardize, is meant to be generic, meaning that we don't care too much about what the artifacts are. It could be software, it could be something else. And also, we don't care too much about the actual contents and interpretation of the statement. So as long as we can serialize them, it doesn't matter too much what is carried there. What is critical is that we agree on the envelope. So and I'm going to review those elements later, so that at least we know who is saying what along the supply chain. So any next slide, please. Yes. So the first protocol is about issuance, and the main issue there, which we are still discussing, and that at the core of it, but is not directly addressed or the architecture, is the identity of issuers. And so we decided that this working group was not about redoing PKIs or identity infrastructure also. Although it's critical for us, we are delegating that to some other standards. So we are using DID to provide long-term identifiers, and that's critical for the whole system, because the transparency service, the append-only log, and the issues are meant to be valid for possibly decades. And at that scale, we can't expect the actual credential use for signing or for authenticating them to have survived. So we need this form of a good, robust infrastructure to deal with identity. At the same time, we don't want to invent something new. So we are reusing, in our case, DID to get there. So the main point of issuance is to pick the payload, but as I said, we are not looking at the payload. So for us, it boils down to the choice of the mandatory headers in the COSI envelope that gets signed. And so there is the issuer that contains the identifier associated with the signature. There is the feed, which is a way for the issuer to refer to the artifact. And so we had some discussion about namespaces and how to standardize feeds. For now, it's still a string. So and that its interpretation is defined by the issuer, and we may need to go beyond that, but for now we are not putting more structure in there. We also have the content type that indicates how to interpret the payload for people who will interpret the payload. And finally, and that's the most open header, we have a registration info that gathers all the input parameters that are supplied by the issuer and that may influence the registration process, in particular, be used as input to the registration policy at the next step. So that might include a timestamp, that might also include references to prior claims that are being modified or derived or extended by the new state transferring that claim being issued. Next slide.
Hank's in the queue. I think it's not on.
Okay. So yeah, with the feed, you said it's at the moment it's just a string. I really want to elaborate on. We had a side discussion all week about the complexity of talking about products, and we assume that currently our working assumption becomes, I think, that feed is of course a structured identifier, and maybe a well-structured composite identifier. And how to do that, I think, will become its own topic that we can really, or should really soon start to discuss on the mail list. Because this is how you talk about the components of your product, or your product life cycle. All these feeds would be related, and that is structured to the identifier that is the feed or the topic in this case you're talking about. That's all. Thanks.
No, that's definitely very important. I guess it is a string because for each use cases, you will have a different format, but we may want to provide generic support for something more general, like maybe it wouldn't change much in the architecture if we said it is a CBOR with a profile that is going to be enforced by for the given supply chain, for example. Next slide. Yes. Okay, so the next step, in a sense, the central step is registration. So there is an entity that submits a signed statement for registration. So it may be the issuer or not. So in particular, it's quite possible that the same signed statement be submitted multiple times or be submitted to multiple transparency services by third parties. And there are good use cases for that. So the transparency service validates the signed statement. So some of the validation is generic. So in particular, At the very least, the transparency service is going to check that the issuer is well identified and that it can, at the time of registration, verify the signature on the incoming envelope of the signed statement. Then there is another open-ended part of the registration policies that depends on the use case, and that may involve, for example, filtering what is the structure of the feed, or whether the issuer is authoritative to talk about that feed. It may also involve processing policies that refer to prior statements, registered on that particular transparency service, or even registered on other transparency services. And as Antoine explained last time, we think there is a lot of value in having expressive, restrictive registration policies, because, and the main argument there is that by having interesting, meaningful registration policies, we can prevent problems with bad or bogus signed statements. So by not registering them, we prevent the problems, and we don't cause confusion, we reduce the volume. So if we can prevent some classes of attacks or some classes of error at that level, that's a good thing to do. By default, otherwise, we are going to record it, and we are going to hold the issuers accountable for what they committed to, so that we can blame them. But again, preventing is better than blaming if we can. The flip side of that is specifying in a SCITT what the registration policy can and cannot do is very hard and open-ended. And so we had plenty of discussion of that, but the initial goal is to first get the generic architecture in place, and then start standardizing some very common form of registration policies, like, for example, ensuring the validation of references to other signed statements, or ensuring the semantics of secure version numbers, for example. So the idea there would be to provide support so that at least there is interop and shared expectations between the parties for everyone who decide to use those kind of policies. We believe many important policies, possibly the most interesting ones, will remain specific to particular supply chains and particular use cases.
Recognize Mike Procock.
Oh, plenty of questions. Sorry, please go ahead. Yes.
Yeah, no worries. And I think I have a microphone now. Yes, Mike Procock here. It seems like opening a can of worms by saying which registration policies should be standardized could go down a serious rat hole, versus saying, how do we describe registration policies? Maybe as a byproduct, we get a few good ones out of that. But at the minimum, we have a system to system way of saying, you know, here are the checks, here's what they apply on, et cetera. And it could be done probably a lot more quickly and efficiently and tested practically from an implementation side. It would also provide a way to hook in test harnesses to actually validate interoperability around policies, which could be really important. So just a thought there, because otherwise we could very easily go down a super rat hole of, well, what about my weird use case, et cetera. So
yes, so for now, what we do is actually very simple. So we have this registration information, and those are parameters that are passed to the function that implements the registration policy, and that is implementation specific, and that's good enough. So we can that's why we got interrupt, and that's what the coding does now. Yes,
exactly.
Now I think if you want to go further to extract more value out of it, it's important that when you verify a transparent statement with some registration info, you sort of know the check that must have been performed by the transparency service. And so agreeing on the interpretation of each of those fields, at least for simple cases, is, I think, something important, but it's going to be best effort. And we are, it's not something we are going to close anytime soon, but I think we should keep going at the easy bits of those policies.
Recognize Henk.
Yeah, hi, this is Henk. Yeah, we there were also side discussion about cozy profile /feed /TYP plus CTY as a mantra. Yeah, and having said all that, policy languages are their own SDO. So maybe referring to them, content typing them is one easy low-hanging fruit that we could do. If we have to really standardize something, it's like categories of what this is intended to do. I'm not sure they're going there. Also, what I actually raised my hand is, I want to point out an interesting in the discrepancy and consistency here. This box says you're sending a signed statement to the transparency service and get back a receipt. And the first implementation I saw was able to retrieve the signed statement independently also. So this is already misleading because praxis shows we might need more operations than a simplified figure 1 can show, right? Yeah, and so that is why I think that use cases will influence operations and effective implementations then.
Yeah, just to elaborate that line down there is the blocking interface that I think we shouldn't mandate. Recognize Hannes.
Yeah, a little bit similar to what Hank was just saying. I think when it comes to registration policies and standardizing them, I think it would be good to make sort of like write something down to be a little bit clearer what we want to do here, because indeed that can be quite tricky if we want to standardize a language to describe policies and something similar. So I would be a little bit, I would postpone this to a later phase when we get the other stuff done.
Yes, for the current status is we have a general discussion of that, but it's pretty short. And then we have, I think, 3 or 4 examples that may be overly specific. So we might want to simplify that until we get a better idea of how far we actually want to go there in the architecture document.
Okay. Recognize Roy Williams.
So Roy Williams, when it comes to registration policy, there's 2 aspects of this we've got to kind of keep separate. One is the policy for identity providers that then the ledger and is validating, generating receipts for. And then there's the vertical configuration for each vertical itself. Like, is there an SBOM for secure supply chain for physical stuff that can be slightly differently? We're going to have to deal with the first one first and have some way to carry the information to deal with future federation. So we have to deal with some of it up front, Hannes. So I understand, I agree with Mike Proak, we have to come up with some framework of how to extend it and carry it, but I don't think we can ignore it in the short term.
Okay, next slide, please.
Okay.
So the first step is validation and audit, and so the main aspect I wanted to recall there is that although we produce the same evidence for everyone, and we make a point that it is shared so that everyone sees the same evidence, we expect different verifiers to have vastly different capabilities and willingness to check the details. So in particular, we anticipate that most consumers of the artifact are just going to verify the receipt for transparency service that they are configured to trust. And as long as that the transparency statement is valid, then they will accept the artifact as genuine. So some consumers, in particular those with that are online and with actual capabilities, may check for more details about the statement. They may parse it in some cases. They may re-verify the issuer signatures or at least the identity. And they may also apply additional local policies before accepting the artifact. And at the other end of the spectrum, we have auditors that are suspicious about the transparency service or are there to keep the transparency service honest. And so those are the most advanced. They will typically keep state and cross-check the different bits of evidence against one another, and also against the receipt collected by other verifiers. And I think something that is not recorded on the slide, but that became quite apparent, is that one class of advanced stateful verifiers is actually other transparency service in some federation cases. So if you have 2 transparency services and one of them is producing transparent statements, and another is recording or depending on them, down the flow, then it typically is an advanced one that we need to keep enough evidence to justify the inclusion of transparent claims checked by another party that is a priori semi-trusted. So that's quite interesting. As an active work item, we are of course discussing what it takes and to access the details, to ask for auxiliary claims, or they should be indexed or they should be retrieved. And so far, we have been treating that as implementation specific. But of course, agreeing on APIs to do that is quite important. So it's an active subject of discussion. So far, we have decided to do very little in the standard for that. But that's probably a place where, as we do more use cases and understand better federation, we may want to be more explicit about what we want out of auditing and out of advanced verifiers. Next slide. Okay, so for the rest of the discussion of the architecture, so I pick a couple of themes that are coming really often in discussions as we present SCITT to other audiences or as part of a regular SCITT meeting. So one of them is scalability, in particular in terms of performance. And of course, for that, we need coding experiments and we need use cases to actually understand how intense the registration process is going to be. But nonetheless, I wanted to summarize what we know about that today. So for issuance, it's not a problem because at least for what we standardize, in as much as it's just a matter of signing and that's fully distributed. So the obvious bottleneck of the architecture has to do with the registration. So that's where we put a lot of effort trying to understand that bottleneck and to minimize it. And the way to make registration scales comes in three different directions. So one of them is batching. So if you look at the details of the format, and in particular the receipt format, it has been designed in such a way that you can countersign, you can issue receipts in batch. So you actually do not need to sign once for every transparent statement that you register. You can do that only from time to time. In fact, some of our implementations only signs for once every 1,000 or every 10,000 of registered transparent statements. So the cryptographic bottleneck is largely diminished. Of course, there is a trade-off with latency. So it's not completely for free, but the Merkle tree is such that it can be built incrementally, and as long as from time to time you sign the updated route, from there you can reproduce receipts for everything that has been registered so far. Hank, yes?
Yeah, this is just a clarifying question. So when could you give us a compelling example when these batches occur? So that you want to have this latency taken into account, and that it's okay to have one receipt for a batch.
Mm-hmm. Oh, you have a receipt for every signed statement. So the receipts really referred to each side. The way they are produced, you can do that in a batch. And so the prototype implementation that we are using, for example, does that feature incrementally, and it's typically configured to delay the production of receipts for every page that you are actually writing and committing to disk, at which point you can, we have kept all the intermediate hashes that are sufficient to respond to everyone who is waiting for the receipt. So in a sense, it's very similar to what John was discussing earlier, where in fact, most implementers will probably only send a promise to issue a receipt soon afterward, and you have to wait a bit, or you have to fetch the receipt once it is ready. And the time scale there is waiting for maybe from 1 millisecond to 1 second, which I think for most supply chain is okay, but maybe not. You have to look at the details of use cases. So the second aspect of registration as a bottleneck has to do with the sheer volume of transparent statements that we are recording. So because it's an app-only log, if you put something in an app-only log and then you lose it, then it is immediately problematic for the transparency service. And so a lot of effort there has gone into making sure that we can keep the actual sign statements and transparent sign statement quite compact. And so the typical way to achieve that is to only include in the statement a commitment or a digest to the actual data. And so if there is gigabytes of SBOM, you can compute a cryptographic commitment like SHA-256 hash, then put that as the body in the transparent statement. And now you can batch thousands of statements in a single page that goes to disk and issue receipts for them at the same time. The third aspect, which is promising, but that we haven't explored that much yet, has to do with federation. The idea being that most people actually don't care about the minute details of all the intermediate transparent claims that are recorded for the production in particular of software. So if you think of a producer transparency service, it may be that you need a different transparent sign claim for every commit so that you can account for every source line by author of what is being pushed into your TCB. Now, as you do releases, you can aggregate them, and so the public-facing transparency service will typically only have one transparent statement for every release, not for every commit. And in that way, by having multiple transparency services that partially mirror the most important transparent statement, we think it can scale up, but that part is not going to be for free. It's going to complicate the distributed aspect of the system we are building.
Can we recognize Haigong Wang in the queue?
Yes, please.
Yeah, hello. This is Haigong from Huawei International. Just a simple question is, normally who will be the verifier? I mean, you see in these slides, there's a related party will verify the transparent claims offline. Could you please give an example? Who will be the verifier?
So in most cases, the verifier will be the consumer of the artifact. So as an example, you receive a new driver and you verify, much in the same way as you verify today a signature on a driver before installing it on your machine. You will verify the receipt for it before installing it in your machine. So the actual user of the artifact, in particular a software artifact, is the most common case of verifiers. The other class of verifier that we are distinguishing is the auditor, who is verifying a large set of related transparent statements to look for inconsistencies. But they are more advanced and there will be fewer of those.
Okay, thank you. Thank you.
Mike Prorock.
Yeah, Mike Perrick here. I was just going to clarify that the RP, so the relying party from the verification side, it's phrased very intentionally, can verify offline claims because there are a lot of those offline scenarios. There's a lot of online scenarios as well. Mm-hmm. That could be an individual, right? That could be a security researcher. It could just as well be a piece of software or multiple pieces of software, say embedded in hardware, embedded in software, or a combination of both. So there's a variety of different entities, right, both virtual and physical, that could be taking that role as the verifier and the relying party. So.
Yeah, so we are coming to the last aspect, which is the verification. And so at face value, verifications should also scale really well, as long as it is offline. So receipts are meant to be verifiable, much in the same way as you verify your signature. So that part scales extremely well. So now if you want more advanced properties, and you are into scenarios where you, offline moves into online, then things are much less clear. And I think the main complication there is if you not only want to have a proof of registration, but also a proof of freshness. So it's not enough to know that it's a driver that has been signed in the past, but you want to know that it's currently the driver that is recommended by your software provider. And for that, I think we need to work more, probably to, my personal preference would be to add support in receipts for at least some kind of freshness with a reasonably coarse grain of time resolution. But that's a place where if you are not careful, then many people can verify offline, but they will think that they need to go to the transparency service to check if there is something more recent. And that is much more frightening from a scalability viewpoint. So freshness is definitely an active issue that we need to look into more carefully.
Yeah, let's not do OCSP again. So I just wanted to make the note, as we're thinking about this and scalability, the picture here is very kind of static and linear. And we have to remember with like the batching and the verification and the offlineness in particular, there are basically two verification scenarios that we need to play to at two ends of the scale. There's an audit, which happens 7 years after the event. You've got infinite money and infinite time to do it. And you will not go back and ask the Transparency Service to mark its own homework because, you know, why would you? So offline, slow, manual verification of receipts at that end is good and fine. But when we start talking about use cases like federating or like automating the software supply chain, that verification is going to happen very, very quickly because you're making real-time decisions based on verifying these things. So just a note that we do need to support both of those at the same time and not invent schemes, multi-part protocols and other things that benefit one and kill the other. Liu Zhang?
Yep.
Hello, everyone. I'm Liu Xiang from Huawei Technologies. And I have just one question. And as we can see from the diagram of architecture, it is apparent that the transparency service is very important in the architecture because it can generate the receipts of the signed statement, and it should be pretty fully trusted by all the stakeholders. Otherwise, the receipt it generated cannot be trusted. And so in this case, in your design or in the design of this draft, in what manner the transparency service will be organized or operated? It is in a fully centralized manner, for example, operated by some centralized organization, or it is operated in a distributed manner or a federated manner?
Okay, no, that's a great question. So that I will try to give the response short, but please, there are at least 2 sections in the architecture discussing that specific issue. So in brief, there are 2 aspects there. So the transparency service is designed in such a way that everyone can check what it is doing. So an auditor can replay, people can compare receipts. And so as soon as a transparency service makes a mistake, either because it is corrupt or because there is a bug, the idea is that it should be as easy as possible for auditors and verifiers to detect that problem and blame the transparency service. So in a sense, it is a very important party, but we minimize the trust by making it easy for everyone to verify and to keep it under scrutiny. So now, how to make it trustworthy is outside the scope of the standard, the architecture. But in the prototype and in the code experiment that we have, there are many ways to achieve that. And so one, the approach I'm the most familiar with in our SCITT prototype is to rely on a combination of trusted hardware and replication. So you operate a distributed consensus between multiple replicas that are cross-checking one another, and each of the replica being operated inside of its own trusted encryption environment on some secure hardware. And so that's one way to get high confidence that the transparency service is not going to misbehave, but it's still going to remain best effort. So crucially, the architecture is all about making it very easy to detect and to blame the transparency service if it starts to misbehave.
All right. Okay. Thank you very much. And I think I agree with you. So how to make the transparent service is pretty trustworthy is pretty important. And maybe, as you just said, it is kind of out of scope of the current standard program, right? So I see. So maybe we can talk about offline. Okay. Thank you.
Hannes had a point. I'll make the point. I locked the queue because we've got 4 more slides and 10 minutes. But if you have a burning desire to ask a question on this, I'll open it again.
I will post it to the mailing list.
Okay.
Okay, so I hope the next slide is less controversial. So I think that's an oversight of what we do. Can you move on to the next slide, please?
I should be able, yes. It said
So in effect, it's more like an oversight of the initial version of the architecture where we forgot a very important capability, which is the ability to use a reference of transparent statement. And so we thought a bit more about it at the last meetings and in between. And so what I think we are converging on is to have a standard way of referring to a claim once it has been made transparent, with the URL that consists of three parts. First of all, the long-term identity of the transparency service who registered it, followed by a locator local to that transparency service. In that case, for example, the registration index into the log of that transparency service. And last but not least, a cryptographic commitment to the whole content of the transparent sign claim, so that you can use the registry identifier and the location to retrieve the full-fledged transparent claim and receipt. But then you can check that they are the ones that were committed to by rehashing them and comparing them to the commitment. And there are many use cases for that. I'm not going to detail them, but we had several examples of how you want one statement to refer to prior statement, or in particular in federation, that becomes critical to be able to do that. One remark about the threat model and the security properties still. We think it's very important to encourage people to actually use references as a way of sharing the information into something transparent and actually verified by all parties. So if everyone has a reference with a commitment to what has been shared, then everyone will benefit from everyone else checking the details of that transparent claim. If instead you are copying the content, including in signature, first of all, it will be less efficient, but also it will open the way for potential inconsistencies and advanced attacks where different parties are passed different copies of what should be the same transparent statement. Next slide. So the last issue, it's for that I know it's quite controversial. So it's also very fresh. That's what we talked the most about at the hackathon last weekend, and it's the ability for registration to actually produce additional information and staple that information to the transparent statement. So in the initial design, we don't do that. So the receipt is essentially a counter signature. It's a bit more than a counter signature because it also tells you the position in the append-only log where the signed statement has been recorded, but that's it. In fact, we found many important use cases where we want to record a bit more important information that is known only at registration time, like a timestamp or references to other claims present in the log and used at that time. And so we are looking for a way to include that data into the resulting transparent statement. And so the next slide shows where we are today. And so the idea is to add this additional registration information that is bound at registration time, and that is called here registration data, as something that is appended to the signed claim before it gets hashed and incorporated into the Merkle tree, so that the inclusion path covers both the initial signed statement plus the information that is selected and appended by the transparency service. And then, as before, to include the receipt that covers now that additional registration data into the receipt that forms a second unprotected header attached to the signed claim to make it transparent and ready for distribution. All right, so that's all I have. If you're happy, if you have to discuss more either now or later, but please join the discussion. Many of the issues I mentioned are being discussed as either as a pull request or as issues or as threads on the mailing list, and your inputs will be super useful. Yes. Thanks.
Good. So Henk, since we do have a couple of minutes, do you want to make your scalability point? I banned you from the queue for the scalability question, but we have a couple of minutes if you. Yeah. Okay.
Okay.
Fine. So thank you then,
Right,
Cedric.
thanks.
And we'll go on to inclusion proofs.
Hannes had a question put on the mail.
Oh yeah, Hannes, do you want to?
You want to ask your question for the list?
Yep. Yeah, I think for the scalability, obviously the points that Cedric raised are important, but I'm wondering whether it's also important to think about the distributed nature of the transparency services. Like we discussed in the conference calls, it may be possible that there are many of them out there, and so if you want to verify data, you obviously have to collect information from various different transparency services, but that requires also trust relationships to be in place, etc., etc. Those tend to scale not as well as, for example, batch signing and sending data. I think that's more complicated.
I found it again.
Good.
In my mind. So there was a question about trustworthiness, and you heard consensus and redundancy protocols, and then there are secure hardware. Secure hardware, of course, means IETF RETS WG output. And there are two interesting boxes here that can take on roles of an attester. And the easiest, so to speak, that we have on the most control is the transparency service. That can be a tester. And the funny thing is, it can store its own attestation results if trustworthy, because it's also an append-on ledger. Sorry, that is nice. But in the end, I mean, every statement issuer can be an attester. And to find its verifier, it could ask its trusted transparency service again, because that could be in there. So there's many cool ways how to combine these the outputs from RATs with boxes here. But I think we cannot demand any supply chain entity today out in the world to be an attester. So that's why we're starting with our own central thing, and then we diaspora outwards.
Yeah, it makes sense. I couldn't help thinking when that came up as well that we should not be tempted or ask questions that try to solve insoluble social problems. And every website now has SSL on it, and the SSL cert will verify, but you still might not give them your money because you don't trust the people behind it. That level of issue still occurs here, and I recommend we not try to solve it in the group if we want to publish something. But yeah, as far as we can hold people transparent and accountable, like using RATs and things, I think that is what we're going to do in the working group. Thank you, guys. So, Ori, cozy inclusion proofs.
Awesome. So I'm Ori Steele, and we're going to be discussing cozy inclusion proofs. And as Hank mentioned earlier, these were previously thought of as counter signatures. John mentioned that was difficult to sort of well, it was difficult for everyone to understand exactly how we were going to make that work. And the receipts draft that's been withdrawn was our first attempt at that. And so what I'm going to talk to you about today is the evolution of that work and the parts of it that we've elevated up to be generic cozy building blocks, and how we are able to make use of these generic cozy building blocks to still get the receipt component that we need to make signed statements into transparent statements. Next slide. So we're going to give a brief recap of what is a receipt, although at this point I suspect you know very well what a receipt is, but receipt is a proof that a SCITT signed statement has been successfully registered in a transparency service. We've talked about what registration policies are and how they can get very complex, and there was some discussion in the chat about, you know, whether we should standardize registration policies and all of these other details. And one thing I want to say is there's some minimal registration policy that's important to be enforced, which is at minimum, we want to verify the issuer identity for the signed statement. Then we want to store the signed statement in an append-only log, compute a Merkle proof for the signed statement. And as we compute that Merkle proof, the structure of that append-only log may become important in the construction of the Merkle root. And so you'll see more about the Merkle tree agility problem in the upcoming slides. But I just want to note, you know, there's more than one append-only log out there, and there's more than one way to compute a Merkle tree from any given log. And so one of the primary challenges that we've been addressing, the reason we've moved the inclusion Merkle tree draft to COSI is to make that generic structure valuable, not just to SCITT, but to anyone who's having these issues with Merkle trees. So after we've computed the Merkle root, we want to sign the Merkle root and include the proof to produce a receipt. Then we want to return the receipt to the submitter, and all of the comments about timing around that and potentially batching operations all apply here. That might be a promise to return a receipt, not a synchronous return of a receipt. Next slide. So how are receipts used? Well, verifiers need only trust one of the challenges, as you can imagine, within the software supply chain ecosystem is there's a lot of different issuers out there, and they may be specialized issuers for just one layer, very complicated software supply chain. And so if, as a consumer of software, you had to become aware of all of the different issuers of signed statements, that could become very burdensome. So one of the benefits of receipts is that verifiers need only trust the issuer of the receipt, not the issuers of all signed statements going into a particular artifact. And so there's a sort of a bundling of trust under a single trusted transparency service there that has some really nice scalability properties. Receipts enable offline verification. We've talked a bunch about that. And receipts are also used in federation, although I prefer not to speak very much about that. Next slide. So this is to answer the question for anyone remaining in the room who feels that we made the wrong choice around countersignatures. We had presented previously at 115. I should mention I'm one of the authors of what has become the COSI Merkle proofs draft for the COSI working group. Well, it's not adopted by the working group, but it's a proposal. ID, but there's work that had been done before by many folks, including Mike, who from Microsoft, who's not here, on the representations of signed statements, signed transparent statements before in the countersignature versions, and so there's been a lot of other contributors that have led to the place where we are today, and so. I want to just sort of comment one more time around why did we think that countersignatures might have been the right approach originally, and why is the approach that we've got today probably a better fit as a more generic building block. So SCITT transparency services act like a kind of electronic notary. They certify the authenticity of the signed statement of the issuer, and they certify any additional registration policies that might apply to that signed statement. That's that registration info parameter from the previous slide. So on a technical level, treating it like a countersignature and metadata sort of makes sense logically. It allows embedding of receipts in the unprotected header, which is a sort of similar thing to countersignatures. And leveraging the detached envelope payload forces verifiers to recompute the Merkle root. So there's structural similarities here, but countersignatures have their signatures over different content, and transparent assigned inclusion proof is a signature over Merkle root, which in turn ensures the integrity of all of the elements that are included in that Merkle root. So while whereas a countersignature secures a first signature, one first signature. So that one-to-many difference is important, and also it makes it. We should be careful about how we represent the algorithm that's at play there, because the algorithm for securing a single signature versus the algorithm for securing many signatures included in a log or as a Merkle tree. These are different algorithms, and it's important that consumers and verifiers understand the algorithms that need to be applied in order to verify the signed inclusion proof. Next slide. So SCITT receipts are cozy Merkle proofs, basically. That's the TLDR here. And this is a link to the draft for cozy Merkle proofs, cozy Merkle tree proofs. This is presented to the cozy working group yesterday, and we're still refining terminology. It's very early, very rough, but this is where the receipts draft has sort of gone. And it's a generic cozy Merkle proof structure. It can be used by us, but it could be used also by anyone else who has need of compact CBOR and cozy compatible representations for Merkle trees, Merkle proof data structures. And there's lots of other use cases for those scenarios, which I'll talk about in a slide or two.
Okay, recognize Mike Progrock.
Yeah, Mike Prorak here. Just a quick question, Ori. Do you see, non-Merkle receipts at some point in the future, or the ability to do that, like, or do you foresee that SCITT receipts will always be Merkle tree based?
That's a good question. So there was the comment about the append-only log, the ledger, or the registry. These are all the old words that we've thrown around this before. And the intention behind those scenarios is to have the transparency service operator be trusted to maintain content. And Merkle trees provide one cryptographic way of ensuring that content has been maintained and providing proof that it's still being held. There are other cryptographic structures out there, like Bloom filters, that have been used in the certificate ecosystem space. And it makes me wonder, are there receipt structures that could use a different cryptographic building block? It's an exciting idea, but so far we've mostly been focused on Merkle tree-based receipt constructions.
Recognize Henk.
So this is Hank trying to quote Russ from Cozy. And he was like immediately asking, wouldn't those proofs require identification of the endpoint that handles the tree? And immediately
Yes.
Your reply was, but there doesn't have to be one. There could be just the tree in itself, in a file, whatever. And then there's no service endpoint. And Russ was basically, okay, this is not a mandatory field, apparently. Maybe it's not even the standard, maybe it's in the profile of that thing. And the thing is, that's my point I'm alluding to, SCITT will profile this generic thing to become the receipt. And I think that's the point. So there will be more in a SCITT receipt structure than is defined in this generic one. And that is actually the point.
Yep. And just quickly to respond to that, that was at the presentation to the Cozy working group. And just so that you all are aware, there's cases where you use a Merkle tree for selective disclosure in a credential use case, where you're intending to prove only these claims and choose not to disclose another set of claims. And in those scenarios, those claims are not going into a database. They're not held long-term. They're part of a message format. And so this draft is meant to support scenarios like that, in addition to scenarios where you're using Merkle trees as part of a verifiable data system, like a database system.
Recognize Cedric.
Yes, my comment is related. I'm aware of another big class of use cases where you need more than Merkle trees. And it's where you want both integrity, like we do in SCITT, but also privacy. So there are cases where you want custom privacy properties. And so what people end up using is Merkle tree-like, but with more complications like verifiable random functions or zero knowledge proof. So it's essentially like a Merkle tree, except that it's cryptographically it's a more complex structure. And so privacy is a big source of complication that we have been avoiding so far.
Yeah, so I had a brief comment on that. Is yes, indeed. That's something I've come across. Just as a sort of member of this working group, asking a question of a member of the COSI working group. Hank's already pointed towards it, but is there any great thinking yet whether support of other things, and not just sort of privacy preserving Merkle trees, which are relatively close? So I've implemented that just by having two roots, and you tie the roots together in a privacy group and it kind of works. So that's quite easy. But if we start going for, you know, DAGs and stuff like that, that just doesn't hold. So is there any thinking about whether the COSI kind of Merkle proof thing or the receipt thing will be variadic internally to say, I am a receipt and I'm this kind of proof, and then have a variable payload, versus having a completely different thing where you have sort of COSI Merkle proof is one type of object, and there's a peer object which is a DAG proof, and there's a peer object which is proof of moon.
So I'm not aware of specific conversations within the COSI working group about that. And as I said, this is an individual draft that's basically brand new, and it's very, you know, generic. I guess the one comment would be a signed Merkle proof is a signature over a Merkle root, and there's the protected header that's there that's also signed over. And that protected header could be used to include additional cryptographic material potentially. And so there is ways to add other things there, or to think about another envelope format that was not COSI sign 1, but that was securing the same CBOR structures that are described in the draft. So there's lots of possible ways to do that. But when you think about most of the ways that Merkle proofs are used, it's usually a signature over a root and a disclosure of an inclusion proof for a given member, or a signature over a root and several members disclosed at once. And in the several members disclosed at once case, you want to make sure that there's some blinding of the leafs, because there's brute force attacks on neighbors. So I think I think there's good arguments to be made that maybe it's, you know, like the blinding thing is a good example of sometimes you need to add some additional cryptography in order to get a new property while still using the base Merkle tree sort of primitives.
Okay.
So when I presented this picture to the COSI working group, it was an application example, but here you've all seen lots of content about what a SCITT receipt is at this point. And I want to be clear, you know, these ideas have moved to an idea, has not been adopted by the COSI working group. And what I'm showing you here is sort of a current structure that, you know, John and I in our implementations during the hackathon have been using, and it's been working, but there's lots of potential changes we could see to what a SCITT receipt is and the profile requirements that it might apply to a signed inclusion proof. So the first point I want to make is, you know, the presence of the ISS field, the KID field, and the ALG field. These are pretty standard COSI structures to folks who are familiar with COSI sign 1. The tree algorithm is the one that we're going to spend a little bit more time talking about. Here, I've given you a few examples of known tree algorithms, and these are all tree algorithms that are based mostly on the idea of, like, there is a database or a service that's maintaining this transparency log or all of the signed statements that it's seen. So there could also be tree algorithms that are just about that message disclosure format thing that I mentioned before. But these are each services that we've seen in the wild that are used to basically produce Merkle proofs that a given document is in a database, for example. And then in the unprotected header, you can see the inclusion path. There's the hashes, which are, if you know about how Merkle trees work, the hashes are how you prove a leaf is included in a root. But there's this extra data bit, and that's because we're very much aware that despite how simple Merkle trees are to construct, everyone who's used them has done something special with the leaf. And so extra data is unavoidable, and extra data is tree algorithm dependent. And you need to know the tree algorithm in order to know how to use the extra data to get to a leaf so that you can prove inclusion in a root. There was some discussion on the COSI list when the draft was first submitted. One of the commenters, Ilari, immediately thought, we can make Merkle trees great finally by using COSI and CBOR structures in their construction. So perhaps we'll see in the future a tree algorithm that's specific to COSI and CBOR structures, and maybe extra data goes away in that one magically, or maybe extra data stays and has some inherent COSI structure or CBOR structure that's important. So then the payload section, that's the Merkle root. And as it says at the bottom, we hope for this COSI Merkle proofs draft to eventually be adopted by the COSI working group, and for SCITT to profile on top of it. That's sort of the current plan of attack. Is this my last slide?
It is, yeah. So that's the punchline. Any more comments or questions for Ori? No, thank you very much. You've actually finished. Oh, you're 1 minute over. When I started saying that, you were bang on time. That's fantastic. Okay, so we've reached the fun end of the day. So if anybody knows any jokes or is a great singer, you can step up now to the open mic. Otherwise, next steps from this are relatively simple. As Hannes already said, we're going to issue a poll for appetite for our interims. I think it's been very beneficial to have them regularly. So a lot of work happens between meetings, which is the right way to do it. But also that means you need to check that regularly and have the discussions. So I think we would intend to certainly have at least bi-weekly and possibly still weekly interims. But the other thing to consider and vote on, of course, is that our current time slot is very convenient for UK and Europe. It's not greatly convenient for Asia. And so if any local delegates here or new members in the sort of Asia Pacific time zone are interested in participating, please do make your voices heard there, and we'll look at the time zone things as well. I think both of us, both I and Hannes, have experience of running 3 time zone meetings with kind of TikTok bi-weekly schedules and things like that. So we're very happy to accommodate it if there's appetite to participate. Anything from you, Hannes? Any other next steps beyond that?
Of course, we will continue, or hopefully continue, with the work on the architecture and use case document. There are a bunch of open issues in the GitHub repository, and I would also be interested to see a show of hands for some volunteers to review architecture or use case, so to actually have some interaction on the mailing list following the meeting, or let's say give folks a few weeks to send in some reviews. That would be nice.
Yeah, certainly. There's been a lot of movement, and so if you're not watching, then you don't get to say afterwards. Cool. Okay, so that's good. Yeah. So in terms of work items, it's the architecture and the use cases. They carry on. I wanted to give an opportunity, as I believe is custom, although I may be mistaken, for Roman to make any comments. No need. Okay, good. So in that case, takeaways from this meeting, as we said, the next steps are there. I think the things to watch out for are, we talk a lot about functional operations, and a huge amount of what goes on the mailing list are in many cases exquisitely detailed descriptions of very specific scenarios that we want to cover. I think what's lost in that often is that we don't necessarily talk about the non-functional generalized case of how quickly do we need to get what to whom, which actually would cover all of them. So if you look at the content of the things here that we all deemed to be the kind of most important things to share, an awful lot of it comes down to the performance and the scalability, the lines on the process chart. And actually the important thing there that I think we haven't covered as well as we might do is to think about the non-functionals, the performance expectations, the physical locations where these various roles might be taking place. And I think we all have different experience that we can bring into that thinking and make this thing better, faster. Recognize, Roy?
One thing you failed to mention, John, is the interoperability between the test images. We have to try figuring out how we're going to scale them up.
Yeah.
So that, and that was the other thing, that make sure that if you're implementing one, please join the conversation of how the heck we can hook these all up and get tests so we don't diverge too much.
Yeah, for sure. Yeah, so the whole point of the hackathon exercise was interop, and heck, yeah, if we diverge in how we're going to be in trouble. So yeah, I mean, I guess the biggest takeaway on that front then is, Mike, are you in the queue? I can't see that anymore. Oh, okay. Yeah, so the biggest takeaway of all is we are moving fast. We have code based on the adopted work groups that seems to work. And obviously, we're very careful, and it's documented all over the place, that anything we're implementing that isn't in an official document is kind of speculative. We'll change it, whatever. There's nothing concrete. No, there's nothing being set in concrete, but we don't make progress on things like this any faster than actually trying it out. So if you have interest in building one of these, or even just interest in being a consumer and seeing how reasonably your software tools or your process tools or document handling tools actually consume this stuff, please do. We've got Slack channels, we've got the GitHub repositories. Please do get involved and hook up your code to the various implementations that we've got available.
John, I wonder whether it's whether we could find maybe 3 volunteers to do a review of the architecture document. I think that would be useful, because specifically if we could find someone who hasn't been in those weekly meetings, that would be extremely helpful feedback to see whether the documents are heading in the right direction, where there are gaps, whether they're understandable, and so on.
Definitely, and it's not too scary. As I say, I gave it blind to 2 software engineers and it worked. So I think it is in a good state to do that. Do we have any volunteers in the room? Oh, we do.
I have a question around that before volunteering. As
Okay.
someone who avoids the weekly meetings just due to working too much. Is there appetite to break or consider breaking apart some of the architecture docs, like to take the architecture doc to a little bit of a higher level, identifying core sections, and identify where sections of the current architecture doc maybe deserve their own draft? Because right now it is pretty unwieldy based on my last reading before this. And if so, cool, I'll jump in and make suggestions. Otherwise, I'm going to stay away from it.
Recognize Roman?
Hi, Roman Janina. To follow up on that, I just want to say, as a process thing, the charter does not constrain how many documents necessarily. So I am flexible, and we'll support if we want to break it up. I would just encourage us, if we do that, that does not inhibit progress on the protocol kind of specs. And then we can, in fact, ensure ourselves, if we break it up, that this is parallelizable, and we're not going to end up having the same set of people working now on many documents, and that we won't make progress.
Yeah, the content is all related. So if we did, I would yield to Roy and Cedric. They're actually working on the thing, but they would have to maintain their connections, but could have separate lives, I think.
The balance between that and the threat models, if we break it up, is a little bit of a concern. So we have to play a little bit of a dance in here, because otherwise it's going to be too wieldy.
Yeah, true. We got two, I think. Yep. It's a very kind gentleman at the back who's volunteered.
So who is the second person? I see Thomas Adiono.
Ah, fab. Thank you.
Who was the second person?
In your chat.
Suzuki-san.
Oh, in the chat. Okay.
Yeah, perfect. Great. Well, that sounds good. So I think, Mike, in answer to your question, there's appetite for a conversation, but we need to be careful. I think that seemed to be the conclusion. Good. Okay. So that's everything then. So I guess unless anybody else wants to take the mic, we are free to go. Thank you very much.
Thank you all.
That,